Hello, everyone. So we're going to do talk about ending injection vulnerabilities. Obviously, we've got quite a lot of stuff that's already happened trying to solve this problem. But we're going to just talk about quickly the injection vulnerabilities just generally. Taint checking, a special type of string. Hello. So, Damla, are you sound? Yeah, I'm unmuted. Okay, fine. Okay, well, okay. So right, yes. So some taint checking stuff, but we'll move on to like a special type of string, handling some oddities, examples in Go, Node, JavaScript, Java, and PHP, the future, and in 10 years' time. So the main thing we're going to be talking about is distinguishing strings from a trusted developer from strings that may be attacker controlled. Now, this was a statement that Mike Samuel made in one of the JavaScript repos. And it's kind of a key thing for, I am sharing the wrong slide. Okay, sorry. This is not going well. Sorry, give me a second, switch over. Stop sharing. Do that. Okay. Okay, so that's a few seconds behind. Right. Okay, so distinguish a string from a trusted developer from strings that may be attacker controlled. Written by Mike Samuel back in March 2019. This basic principle will allow us to actually stop injection vulnerabilities from being a problem. What we can also do is use information where so Christoph Kern did a talk back in 2015 or 2016 on preventing security bugs through software design. Christoph works at Google, and this is how they have approached the problem themselves, and it has been very effective at stopping these problems. It's also included in the Building Secure and Reliable Systems book from a few different Googlers. If you do get this book, if you just turn to page 266, there's about 4 or 5 pages on this basic concept. Right, so our actual talk today, we're going to use 2 characters. Thank you for Toby Fox. Undyne is going to be our defender, and Spamton is going to be our attacker. This is from Undertale and Deltarune. So, injection vulnerabilities. This is the classic, simple example where you've got the SQL query and user data has been appended onto the end of it. The developer thinks this will be how it works, and it's great. You know, it does actually work. But unfortunately, when you have Spamton come along, Spamton will just append this onto the end, and it will be, you know, -1 to sort of probably kill off anything from the user table. Not actually going to return anything from there. You use the union query, and we'll then select from the admin table. So now Spamton is looking into the admin table, who probably shouldn't be doing that. Now we've been able to solve this for a while with prepared parameterized queries. What we do is we select from, basically you make your SQL as a string, as a programmer defined string. And what we do is we send that to the database where it will parse it, it will create its query execution plan. And then as a separate step, the user data comes in and replaces those question marks, or might be named parameters. This means the database does all of its work with the programmer defined string. Another approach, sorry, that works. Another approach is we can use database abstractions, because writing SQL is not exactly people's favorite way of doing things, and the database abstraction can help us do other things like linking up to objects and different methods to, you know, make our lives easier. Now, most abstractions will try to allow you to filter. And what they'll do is they'll give you a method of sort of limiting those things. Usually what you have to do is provide your developer's defined string up front, and then you provide any user values separately. In this case, at first we have the author ID, and we just simply pass in the ID separately. Sometimes there is no user data, and it is just simply, the author ID is null. Next, we have a date in brackets published, because let's say the published date is a time date time, so it has a date and a time. The date function allows us to filter just to the date component, and you can do that. Not the most efficient, but some people do it this way, and all that is fine. When we start going a little bit off track is when you sort of take your, maybe hard-coded bit, you say word count is greater than 1,000, maybe because we're looking for long-form articles. But imagine a situation where the users want to be able to configure what they consider to be a long-form article. Now, if you're to do this properly, according to the documentation, you would use the comma and you provide the count in separately. But imagine this job has been given to a junior developer, or maybe you just make a mistake. And what you instead do is use concatenation. So the word count is greater than the concatenated bit of the count. So the database abstraction has no idea that user data has been included in this. And while this will work for the developer testing it, because count for them is 1,000 or whatever number it's going to be, when Spamton comes along, our little attacker, they'll do word count greater than word count, which is false. You can't have something greater than itself. And then then Spamton just does a union select to append more data onto the end of that query. So that database abstraction has hidden some of the details that has allowed another injection vulnerability to come in. Another example is if you did a order by. So the database abstraction allows you just to provide the order by query. And if it goes from the URL, which it sometimes does, it can just be appended like this. And that is working. But if Spamton's coming along, they might do this. Now, I quite like the order by problem, because order by is limited to what it can and can't do. You can't easily do a union onto this, but what you can do is do it character by character extraction of the data. The way to do it is you do select one from admin where ID equals 6, and what you're doing there is you're saying, the attacker is focusing on one thing. Sorry, 2 seconds. Okay, right, sorry. Let's go back to this. Okay, so yes. So we're going to select from the admin table where ID equals 6 and the password is this. Why this query is quite fascinating is because if it doesn't return any rows at all, that's kind of 0-ish. If it does match something, it becomes 1. When you are running this query, if the ID equals the number 1, then user 1 moves to the bottom of the list. So in this case, let's say the ID does not match. Amy Anderson, who has an ID of 1, does not move. Reissue the query with a B, and let's say it does match. Suddenly Amy drops to the bottom. And now you know what the first character of the password field is. And then Spamton will just build up over and over again. Spamton probably wouldn't do with ABC, probably start with S, most common character. And then once you get a few characters under the belt, we start using words and things. And obviously, we know not to store passwords in plain text, but it's just a nice, easy example to show how an order by can be exploited with a database abstraction. And people aren't thinking this is going to be a problem when it is. So going from SQL, we've got some HTML. This is your classic HTML encoding problem. what we're going to do is just basically do that. Spamton just puts in the script tag and is running the evil alert. How we deal with this is we use templating engines. You either get your HTML template from a file, or in this case, we're going to use a string, a programmer-defined string. And you put that in the first argument, and then you provide the values separately, so it can be filled out. This is how it works. You do have to be careful that your templating engine is actually context aware. Some templating engines are much too simple for this. But for example, if you're putting a URL into a href, that href attribute should not contain JavaScript. And that's why a templating engine needs to be context aware. Another example is command line injection. This is an example. Obviously, you're a programmer. You don't want to rebuild grep. Grep will allow you to do a search through the file. But in this case, we've not escaped the value. We just included it. So Spamton comes along and just puts in double quotes, path to secrets, semicolon, and then a hash to comment out the rest of the line. And now Spamton is seeing the entire contents of the secrets file. So how do we stop these mistakes? There is a technique called taint checking, where variables are noted if they are tainted or untainted. It kind of works, but as we'll see, there are a couple of issues. So how does it work? First of all, you have a string, and it's because it's defined in the source code, it is untainted. Therefore, the variable, in this case HTML, is marked as untainted. In this case, we have the string, the paragraph hi, and that's untainted. Then we have a variable name, which is tainted. And then you have another string, which is for untainted. And then that HTML is now considered untainted, and our defender, templating engine or whatever, can stop it. It can say, no, not having that. I'm rejecting that. So with tainting, or taint checking, what you do is use escaping, which is risky, and we'll show you how that is. So you've got untainted, you've got your tainted variable, and then the final bit of untainted at the end. By using this function, HTML special cars, we're basically HTML encoding that value, and we're escaping it to make it safe. And in this case, it works perfectly. It's good, brilliant. The script tag that Spamton has put in has been HTML encoded. That variable is considered untainted, and we're happy. But unfortunately, taint checking incorrectly assumes that escaping makes a value safe for any context, and that's where it falls apart. With the untainted one, this one, we're going to have the untainted thing, tainted, untainted, and we do the escaping as usual. But you'll notice that we're not actually having to encode anything in Spamton's thing, because in the link context, you can put JavaScript : alert, and HTML encoding does not do anything to that, and that has worked, and it has created this false sense of security, because now the HTML is considered untainted and it's safe in theory. This is one of my favorites. You've got your image tag, which is untainted. You've got your tainted URL, and that. The thing that sort of trips people up is they think, well, it's image, it's the src attribute. You can't put any JavaScript in that. It should be fine. But I'm missing some quote marks, which means that the attacker can now just do /, so the browser will just download the home page for the image and then have an on error alert. There is a mitigation you can put in place called the content security policy, but that's another topic. It has still allowed this to happen. This is still a problem because the escaping is not context aware. And then this is my favorite. Let's put on some quote marks. This should work, but there's a trick question to this one, because while this now all seems to make sense and it should seem safe, it's still technically possible in the PHP language to do this. And the reason being is that before PHP 8.1, single quotes were not encoded by default. I've managed to get that changed for 8.1. If it breaks anything, then you can complain to me, but I think it's probably because you've got a problem that you need to fix. But anyway, there we go. And another example here is SQL, which is where ID equals. You've got your escaping. Is this safe? Still missing the quotes, and therefore this kind of escaping is again flawed. And Spamton is able to extract information from the admin table. So taint checking is close. You know, it's got the right idea, but escaping should be done by a third-party library, a library which understands what it's doing. You know, it understands the context in which it works. A database library knows about SQL. HTML templating engine understands about HTML. Sorry, I put that wrong. So instead, we can simplify it by looking for strings from a trusted developer and don't handle any escaping. Or in short, safe versus unsafe. Safe, when talking about injection vulnerabilities, and that is kind of important, is a string defined by a programmer, as in the source code, and everything else is considered unsafe. So we go back to our prepared parameterized query, and that is safe. The ID is unsafe, but they're provided separately, so it's good. Everyone's happy. If the developer had made a mistake in their parameterization, they would do this, the safe versus unsafe. Together, that is considered unsafe, and then our database abstraction can reject that. It can go, no, not having it. It has been damaged by a value that was not written by a developer. Same with the HTML template engine. You've got a safe string, your unsafe string. That's good. As soon as you do something wrong, you know, the developer's made a mistake. You know, you've got your safe, unsafe, is that, and then the you know, the templating engine can go, no, not having this, I'm not accepting it. And same with the command line. Keep it, your developer defines strings separately from the values from the user. And again, that has worked fine. Go back to the mistake that we made earlier, where we just put in the user value. Those are fine, and again, rejected by the function. And this will go back to the database abstraction with the ORM. We're going to keep, you know, the where the value is greater than date. Date comes from user, kept separate, and that's fine. But again, I'm just going to stress this. Remember, we're only talking about safety in terms of injection vulnerabilities. If Spamton had put in a value of 000, you know, basically year 0, the publish date is greater than 0, which basically means everything. And a select statement probably not means anything, but for example, a delete statement, you might be deleting a little bit more than you can think of. That is not really a problem we can solve. That is very much a developer having to choose their boundaries. We are focused on injection vulnerabilities here. And to make that point even clearer, same thing again, string, it's safe versus unsafe. That's technically fine, but as soon as you allow Spamton to specify the path and that path becomes just a /, you get the classic rm-rf/. And yes, I know RM doesn't actually do that anymore. For a lot of the times now, you have to put in a special flag to say, yes, I want to destroy my system. Okay, so dealing with special cases, because it might seem like you can't always deal with everything. So the classic one that comes up when this conversation happens is the where in clause, or the in operator. You say where ID is in this list of IDs, and you typically give it a list of IDs to deal with, and it will return those records. This is a nice and quick way of doing it, but you are technically allowing user values into the SQL, and this can be dangerous, especially if you don't remember to ensure they are all integers. If you don't, Spamton comes along and puts in whatever they like into this. And if you start looking at large code bases which do this, it is surprisingly common how often that actually happens, where the values that have been imploded into the where in haven't actually been converted to an integer. If you look at WordPress, for example, there's a few cases there. Fortunately, they have other mitigations in place, but it's not exactly consistent. So one way of doing this is you use a function or some way of just basically putting in that number of parameters, as in just question marks, and then the database will fulfill those later. The inParameters function in this case is just simply taking a count of how many question marks to add. And by doing it this way, you are creating a string that has been defined by the developers. And it is a string that is in the source code, no user input. If you want to get fancy, you could simplify this a little bit by using an array fill type function, where it will build up an array of that many elements of question marks, and then it will implode them or join them together with a comma. As with anything like these, you've got to be careful with no IDs, but that is going to be always a problem no matter what. The other one that comes up is table names and field names. These are problematic because they can't be parameterized. They can't go into the parameterized bit. They need to go into that original SQL sent to the database first. So, you know, it's quite tempting to put them on. You can escape them to make sure it is still a field. But should you allow any field to be in your SQL? Can the attacker order your, I don't know, list of contributors by their email address? You know, it's probably not the field that you want to allow them to sort by. So one way around this, or one way you should be dealing with it, is you have your allow list. So you have an array of allowed fields that you can order by. And by using this array-like structure, you can, first of all, you can search through it. So the order field variable there is saying what the user would like to sort it by. You search through that array to see if you can find it. If you find it, then you bring back the index for it, which is where you get the order ID variable. So if it's ordered by the email field, then that would be 1, because we're zero-based indexing. And then when you come to do the actual order by, you reuse that array of programmer-defined strings to pull out the one that you want. And therefore, you now have a nice clean thing, which ensures that you are only allowing the ordering by certain things. And that's the way we go. There is one other thing, which is the config values, which come from, you know, INI files, like JSON, YAML. Because they've come external, the programming language can't say that I was a programmer-defined string. In these cases, well, we'll have to cover that in the next section, but in short, the library needs to handle these safely. They need to know what they are and to handle it in its own way. Okay, so ending injection vulnerabilities in Go. Go programming language is probably the only one that I've found which can do all of this by itself with no dependencies. And it's quite simple in a way, once you've got your head around this first little bit. I'd like to thank Dima, who checked over my code, because I'm not a Go programmer, and Roberto, who worked on the Go Safe HTML library, who kind of wrote up this description. So first of all, we're going to look at the code that would be in the library. So how would the library go about this? First of all, they make a package in Go, and they create a type of string constant, and it's a string. You'll notice that it starts with a lowercase s. In Go, that means that is not exported. So anyone using this library won't be able to use it. Then moving on, we have a method that the library provides to code that's calling it. You notice this one has a capital O at the beginning. That means it is exported so anyone can use it. And as its input, the thing it takes as its first argument, and in this case its only argument, it's saying it needs it to be a string constant, as mentioned on line 3, the defined thing. So we'll put that to the side, and now we'll look at the code that the user of that library is going to write. First of all, we have some basic code for just simply getting the person's name. It just says, you know, what's your name? And it just reads it from input. This is our way of testing that we are working with untrusted data. Now, to actually call it, we're going to call the example package, which is now going over to the library, and we call the method only accept strings from, well, only accept string constant. And we pass in hello as an untyped string. When Go is compiling this code, it will use a thing called type conversion to turn this into the string constant. This allows it to, basically, it's an automatic thing, and it converts it and everyone's happy, it matches the requirements for that method. When you come to the next one, which is the developer doing something wrong, this time they're just passing in the your name variable, which contains untrusted data, it cannot be converted to a string constant at compile time. So when you're compiling it, the compiler rejects it. It says, you know, cannot use your name because it's just a type string. And that's it, you can't compile the code. That's it, you're done. So now the developer has to fix their code before they can continue, and they can't make any mistakes. And this is how it works in the Go Safety HTML library, or to give its full name, on GitHub. Now, in the Go Safe HTML package, there are about 3 or 4 different things they deal with. HTML templates, there's the JavaScript, and there's the styling stuff. I'm going to start with the JavaScript one because it's the simplest, really. You've got the string from constant, and that is basically a string that has to be written by the developer. If you're writing JavaScript, it has to be written by the developer. If you write as script from constant and you pass in any user data or anything that wasn't defined by the programmer, then this method will reject it. It'll say, no, not having it. You have to use something else. And that's what I mean by it's the simple one. You can just do A and B. When you come to the HTML side of things, you go to the template package first, and you say a method of must pass and execute to HTML, and then you put in your untyped string of hello. Safe HTML escaped is the second line, and that's where you take the user value and you put it in, and then the variable, the third one, C, finishes this off with a closing paragraph tag. And then we use the Safe HTML package to then concatenate those 3 things together. And that's how you do it correctly. Everyone's happy, all good. If the developer did this wrong, must pass and execute to HTML, your name, this would be rejected. You know, it just wouldn't allow that. Likewise, if during the concatenation phase, you did A, your name, C, that'll also be rejected. So the program will not compile. Okay, so that's Go. Now, ending injection vulnerabilities with Node and JavaScript. The JavaScript stuff is still coming. It's going through the standards process, and it's kind of working there. So here is a template literal. This has probably caused quite a lot of problems over the years, because it made it even easier to do the wrong thing, because it makes it easier to include a value without any kind of escaping at all. I was not happy when I saw this coming to the spec, but hey ho, because it just allows them to be, you know, those values to be included, no thoughts given. However, there is a thing called tagged templates. It uses the same principle of using the backticks for templating, but it uses a function called, in this case, I'm naming it my template. You define the function as such. The first argument is receives an array of the pieces that make up the template, and then from that point on you have your values. If you just console log them, it is just simply an array like that. Then when you do the values, that's your additional arguments, they come in, and it means that the function my template could actually build up the HTML template or the content, knowing the context in which every variable was used in. There's a small snag to this, though. The developer could use it wrong. I don't know if you noticed, but it's not usual to see a function being called without the brackets around it. So I've seen it before now where the developer has gone, well, that's a function, so I need to put brackets around it. And then they'll complain it's not receiving an array, and then they put array brackets around it. And therefore, what the function receives is basically everything inside the first part, which is what all the developer-defined strings are supposed to be, and nothing in the second array. Another approach that I saw, same project, they'd actually split it out into separate parts in the array, and there it goes like that. The solution to this is a function that's being developed at the moment. There's a polyfill in Node, and it's being spec'd out at the moment in JavaScript, where it's basically is template object. It's a really simple function, and it just simply says, is that first argument from a template? And if it's not, then you throw a mistake. So in this case, where it's been used correctly, all good, everyone's happy. And in this case, it was not provided as a template object, and therefore it's able to reject it, and you get an exception thrown. How this works in Node: first of all, you install isTemplate object, which is it's a polyfill for now. Hopefully later it will come in. And it's made from Mike Samuel, and basically you just have that function. Everything on here is basically what was shown earlier. When you run it, you get the true for the passing one and the 2 falses for the failing ones, because it's worked as it should do. So you can do a little bit more, and you could throw exceptions or whatever. This is coming soon to JavaScript. It's a proposal in the TC39 group at the moment. And I'd like to say thanks to Christoph, who's helped me talk this through, and again, Mike Samuel for sort of starting this off. Okay, so a different approach. Node also can use the Google closure library. First of all, you have to install it. And this one is basically, you require that library and you include the goo.string.const thing. Here's our getting the name, the untrusted data. And while using the goostring_const from method, it will check that it has come from that it is actually a programmer-defined string. Now, if you just write it through Node normally, it does nothing. It actually makes no difference at all. But if you download the closure compiler, which is an extra step, and then you run that compiler, then it will reject that. So, for example, in this case, it has identified the error on line 14 and said it's not going any further. JavaScript and trusted types is another thing which is coming in, where you have the trusted types, which is a technology which is already in the browser, but it's looked at being extended. At the moment, what you do is you set a content security policy header. You say that trusted types are required for the script environment, because in the future we might have CSS and everything else. And we set the types to none for now. This code is fine because the output element using the text content API is a perfectly safe API. It is a good API to use. But inner HTML is not safe. It is one of quite a few different APIs which are dangerous. It's very easy to make mistakes with it. So trusted types allows us to, by default, block the use of these dangerous APIs. The way around it, if you really do need it for those few cases, is you make a trusted type. The reason this is quite useful is it means it's easier to audit, so that the browser basically ensures that you're using it correctly most of the time, but when you're auditing the code, you just look for these policies. The policy is very much just a JavaScript object. It's our trusted type, and it just simply has a few methods on it. You only have to have one. Now, in this case, I kept it simple by just simply returning the value, not doing any checking on it. That kind of misses the point, really. You should be using something like DOM Purify or the new Sanitizer API, which has been developed at the moment, to check it. Once you've got that set up, you tell the browser that you trust this object for trusted types. And it's creating a policy based on that. You need to specify this in the header to say, this is the one I'm going to be using. And then when you actually go to use it, as long as you use that method of my trusted type create HTML, it's allowed through. Now, that's a quick tour on trusted types, but you'll notice there's a lot of code here for something. So this is where things are going to be working. What we're going to be looking for, hopefully, in the future is trusted types dot from literal, because if it's written by the programmer, then it can be allowed through. Who cares? We trust the programmer, and as long as it's defined in the source code, there's no chance of, in this case, a DOM-based cross-site scripting vulnerability. Okay, so that's the JavaScript and Node stuff. Now we're going to look at Java. Java doesn't do it in the language itself, but we have to use a package called error-prone, again, developed by Google. It runs extra checks at compile time. Because it's Java, we're going to need to use a build tool. I'm using Maven in this case. So I include that as a dependency, and then I set up the compiler configuration, all of which is set up on the, or described on the website. It does install a few dependencies, but once it's running, all you have to do is you import the annotations, the compile time constant annotation, and then for the library's public methods, it will specify compile time constant for those sensitive strings, and it's just simply at compile time constant, and that's it. So when we actually start using this, we get the user data, the untrusted stuff, and if we call a sensitive function with a compile time constant, it's fine, it's happy with that. But if you do it with a user value, which is not programmer defined, then the compiler will complain and it will reject it. It says, no, not having that. There is also for Java a project called Google GWT, where there is a safe HTML from safe constant method. I couldn't get this working, and I have a feeling this project might have been abandoned quite a while, considering they haven't actually even updated it to use HTTPS, which for a Google project is questionable. With C++, I couldn't really work out how they were doing it. If you're looking at the Building Secure and Reliable Systems book that I mentioned at the beginning, they do make this statement of using a template constructor that depends on each character value in the string. That was it. That's all they said. I have no idea what they mean by that. And also Google have a document saying about using safe HTML types as an overview. And this was basically the statement they made, and that was it. So I'm just going to go, I've got nothing to go with that. So ending engineering vulnerabilities in PHP. This is done through static analysis. So you run this as a check over your entire project before you publish it. This one I'm going to start off with using SARM. And I'd like to thank Matthew Brown, who put this into SARM a few months ago. First of all, you just install it. You use typical composer. It installs all its dependencies. Then you initialize SARM. You need to make sure that the SARM is at a level 3 or stricter, where level 1 is the most strict. And when you actually are, as a library developer, you define that certain arguments for your methods are literal strings. That's the type you particularly want, as in it was defined as a literal. So when you actually are using this library, with the code at the bottom, when you actually concatenate in the user value, that is rejected. And in this case, SARM will error for you or complain. So that's not good enough. That is no longer a literal string. When you look at PHP Stan, which is another static analysis tool in PHP world, I'd like to thank Andre for adding this again a couple of months ago. Again, you install, not as many dependencies. PHP Stan has a slight difference here. You need to be 5 or stricter if you're only taking a single type. So you're only accepting literal strings. It has to be 7 or stricter if there are multiple types involved. For example, you're saying a literal string or an array, something like that. And this is inverted. It's level 9 is the most strict at the moment. And it's pretty much exactly the same. You say the type is a literal string. You've got your code and it's rejected straight away. So that's kind of what we can do today. The future how future programming languages can help. The thing that I would like to point out is static analysis, while it's a great tool, is not used by most developers. JetBrains did a survey early part of this year, and PHP developers was about 33%, used it, 66 not. A little bit more for other languages, but it seemed to be about the same. And while I'd like to say that was good news, a third of developers doing it, I kind of feel like this survey is a little bit biased because it implied that most PHP developers are Laravel developers, which is a great framework, don't get me wrong. But if you look at the world of how many websites are built in Laravel, let's just say that WordPress might be a little bit ahead on a global scale. So the number of developers on a much wider scale might be a bit biased. So I would suggest that maybe it's less than a third of developers use static analysis. And also remembering that people we actually care about the most, the ones who make the most mistakes, are probably not using static analysis either. So last year, we put together an is-literal RFC for PHP. And I'd like to thank Joe Watkins and Mate Kokis for doing that. Joe did the implementation and Mate did the performance checking because we want to make sure we're not going to cause any problems. Unfortunately, it did fail, but that was mostly down to communication issues and concerns about performance, which didn't turn out to be any problem at all. And also because we put the vote up on the last day of before feature freeze, and people got a little bit unsure about it. So it is readable. The RFC's there. The implementation there, the patch is also there, and it works. I'm using it on my machine, and it has been fantastic. It has no dependencies because it's actually built into the language. It is actually easy to use. There's no need to use static analysis, but it works very well with it because once the static analysis knows that it's there, it's all good. And it works with existing code and libraries. So some of the things you saw earlier, for example, the Go stuff, it would have kind of required people to rewrite stuff into using query builders and just working a different way. Whereas a lot of code today does use concatenation, and it's concatenation of developer-defined strings. So there we go. And also the advantage of using a function like this is you can choose how to handle the mistakes. You could log to a file, you could write to a database, call an API, throw an exception for the really paranoid people, or do nothing if you just don't care. And one of the beauties of this is it means it doesn't require libraries don't require the developers to read and understand all of their documentation because they're complicated enough as it is. Trying to remember what argument allows SQL or not, and what bits, how every part of it works is important. And it also doesn't rely on developers never making a mistake. You noticed earlier there was it was just a single character difference. It was a comma to separate the two, or a dot which did the concatenation. Very simple mistake to make. And the other advantage of this is developers will be warned as they write the code. So you talk about people pushing left for their development practices. IDEs, once they know about this type, would be able to sort of go, oh, they can highlight it as you type the keys, or just have it trigger as soon as they run that code for the very first time. In terms of performance impact, we got a 0.47% performance impact, and that was kind of, we were trying to be pessimistic on that one. PHP is roughly 30% faster anyway, so it's dwarfed by that. And also we're using the Symfony demo, which is quite complex, and we couldn't even get it to connect to the database because by connecting to the database introduced too much variability. So the real world performance impact is going to be less than that. So how would it work? That's it really. On screen, first of all, you do a function exists because we need to look for backwards compatibility. If it doesn't exist yet, don't use it. And if the variable is not a literal, then you can throw an exception. And in this case, I'm trying to do it as a library. So the library might define this as a private function that it can use every time it needs to check this. And that's it. It's basically when the query method is called, it just checks that SQL is literal. But you might think that's a bit too strict, and that's fair enough. So how about this? Also,
hi, Craig. Sorry to cut you short, but we have maybe 1 minute to wrap it up, and then we will move to Q&A.
Yep. Okay. Cool. So you've got your protection level 0, 1, 0. There. The is literal check is a little bit more expanded. We start off again with the standard thing, but we invert it. So if the function doesn't exist, or it is a literal, then good to go. Otherwise, it's an instance of unsafe value. Protection level is 0, 1, and you can either throw an exception or just trigger an error. This is an unsafe value. This is fairly standard practice, just wrapping up a value into that object. Why you would do this, I'm not entirely sure, but let's say you needed to do something unsafe, but the advantage of this means it's easier for an auditor to find. And identifiers, well, if you look at the query method, you can introduce a new argument of identifiers, which are an array. That gets applied after you've checked the literal check. So you do the literal check on the SQL, and then you do it on there, and you're just checking the names and the identifiers are matching a certain pattern. I'm being very restrictive with A to Z, 0 to 9. And that's how we talked about those INI values, the JSON things, and then it just sends up to a database, and that's how it gets checked. And so the actual code that the person writes is that. This is the example of using identifiers, which is very rarely needed, but it's there anyway. The ORM approach would just do the similar sort of thing, and that's the order by example. CLI, a very simple check at the beginning is just doing an is literal. Again, we could use the similar things at the beginning. That was just me showing how you apply those parameters, escaping all values, running command, and that's how it would appear for the user. First argument is checked, and that's good. If you did it wrong, it would be rejected, and we're good. HTML, same. And move on from that. This was a 300-line example of how to do a templating engine like that. Protection level, allowed tags, passing in XML, because XML gives you a nice quality in theory. Node to walk in, find the question mark parameters, HTML, checking parameters, and that's basically how it will appear to be used on the other side. That's good. Span, you can make templates reusable. That's including the HTML, that gets rejected. This one is fine when it's a normal link, but it's rejected when it's a JavaScript. And here is an example of that. So, and I'm going to sort of skip over this one because that's future stuff. Yeah.
Thanks.
Okay.
Thanks very much.